to record this meeting. It is recording now. Great. Okay. It's okay. It's not that important, subtracting and patching. Anyway, so how does our CNC machining process work, right? So the CNC machines, they run on what's called G code, and it's similar to like a binary on your computer, like the .exe files, if you're taking coding classes. And G code is like very low level. So if you see on the top picture here, that's what G code actually looks like, right? And so what it is like it tells the CNC, move this amount in the X, in the Y, and the Z, and that you do that for like all your parts and things. So if you imagine, right, if you had like a complex gearbox plate and you had to write all this code by hand, that would be very tedious. So that's why we don't write G code by hand. What we do is called CAM, where we basically tell the computer, we're going to do these 5 things, and it will create the G code for us, similar to how you compile something, right? And that process is called post-processing, where you take your information, like I want to cut these shapes out, and post-processing will compile it into G code that you can use for cutting your parts out. And then we just take that G code file, we put it on a USB, put it on either of the CNCs, and we cut it out. And the actual process of how do you plug the USB in and then cut everything out on the CNC, we'll do that when we're in person, but for now we'll just focus on CAM. Yeah, so the first important thing about CNC and just like machining in general is the difference between drill and end mill. Some of you guys might already know this. In case you don't know, that's why I have it here. So you guys are all used to seeing drill bits, right? It's just, it has a spiral on it and there's sharp edges. And so if you were to spin it and go upward, if you were to go down with something into it, it will cut out a hole. And the size of that hole would be the size of this drill bit, right? The difference with an end mill, even though it looks similar because it has that spiral shape, is that the end mill has sharp sides, right? If you look on the drill bit, these sides here are very smooth. Like if you put your hand there, right, it wouldn't cut you. This is smooth metal. But if you put your hand on the end mill, it would actually cut you, right? And especially if you like move it along, it'll cut you really badly. And I know that from experience. So that's why you don't like hold the end mill where the sharp part is, right? So that's the difference. And the way that difference happens in the CNC is that if you spin a drill bit, it'll just make a hole, like a vertical hole, right? But if you spin an end mill and you were to move it along a piece of aluminum, it would actually cut that shape out. It would cut whatever it's in its way, right? And I think I have a video for that here as well, right? There's a video of an end mill cutting stuff just so that you can see how it works, right? So take my word for that, it's spinning, you can kind of see it. But if you see it, it's spinning and it's cutting out whatever in its way, right? You see there's like that little slot that's being made behind the end mill, right? And you see all these small pieces that are flying out. Those are what we call chips in machining. Basically what it is like whatever it's cutting, it cuts them out into these small like pieces that we call chips. And that's what like the waste is basically. On the Laguna, we have a vacuum kind of thing. It's called dust collector. So that sucks up all these chips. But on the Omeo, we don't have that right now. So all the chips basically go on the floor and on the table itself. And we have a brush there to clean it out. And then sometimes you might step on the chips, which is great because then you can slide on the floor. But that's besides the point. Where's the next slide? Oh, no. There we go. Okay. All right. So the next part, right? So how the CAM process actually works. So you'll start with a flat piece of aluminum. There's nothing on it, right? And then we use drill bits for most of our screw holes and rivet holes and any other holes that are less than ½ inch in diameter, right? So are there bigger drill bits, bigger than ½ inch? Yes. But we might have some, but we don't usually use them. Also, they're really big, so it's hard to put them into the CNC. And what you do is, you know, you just go in, drill holes with a drill bit, spin it. It's just like what you guys do with manual drills. And this will be for anything like even the electronic screws, like the 440s, anything from there up to like a 1/4 and even bigger, like random sizes. And then the next 2 steps are like pocketing / bearing holes. So for end mills, that's what we do with end mills. You see how the pockets and the bearing holes are really large size. So we don't have we don't use a drill bit that's that big in diameter. So what we instead do is we take an end mill and we just cut out that large circular portion. And same thing with pocketing, these irregular shapes that are really big. We use an Elmo to cut that shape out. And then the final part of the process is cutting out the actual final shape. Because if you look at this middle picture, right, there's a bunch of holes and pockets, but there's nothing you can put on a robot. It's just a piece of rectangle. So that's, oh, what happened? Okay. What you have to do is you have to cut out the final shape. And that, if you see this blue outline here, that's the final shape we cut out using an end mill. So yeah, that's what you use end mills for. Pocketing, large bearing holes, just large holes, anything bigger than ½ inch generally. And the final shape, The drill bits are only for screw holes and rivet holes. 5/32 rivets, 3/16 rivets, anything in the middle. All right. So the materials we use / tools we use, right? So we mainly cut 3 type of things. We cut polycarb sheets, flat pieces of polycarb. They have like 3 different sizes in them as well, but they're polycarb sheets, aluminum sheets, and then 2x1, 1x1s, 2x2s, that kind of stuff. So polycarb is the easiest to cut. It's like the CNC version of a knife in a butter. Like it's really easy. And even if you messed up your cam, right? It's like your first time you mess something up, something's too fast. Most likely the polycarb will like bend or will break, but your CNC will be fine and your cutter end mill will be fine. 2x1s, they're made out of aluminum, so they're a lot harder to cut, right? But the thing with 2x1s is generally we use like the hollow 2x1s, right? They have a thickness of an 1/8 inch or 16th inch, which is very thin. And so you can get away with like mistakes on some cases. If it's too aggressive, you're gonna break stuff, but it's generally fine. Aluminum sheets are basically like the harder things to cut because if you do make mistakes, it generally ends up with really loud noises that tell you something's about to break. And if you don't do anything about it, it'll break. Especially 1/4 inch aluminum that we use for like drivetrains and stuff. So that's like the general tier of things. So keep that in mind. Like when you're doing cam, right? We have set templates that you can start off of, which is a safe number. But if you want to go faster with polycarb, you can take things up really high and it'll be okay for the most part. But with aluminum, you don't want to be doing that because if you do that, you'll break stuff.
I also want to say that the stuff that Jatin has on the slide, that's what we made. That's what we cut on the CNC. So anything else, that's usually done with the lathe or the mill. And for example, like all the shafts, that's all done on the lathe. So that's just something like that's where I'm just trying to show you like that's where the trade-off, like not really trade-offs go, but that's where the responsibilities of each machine sort of goes. So anything that's super complex or like needs like blocks of aluminum, like something that's other than a 2x1, that goes to the mill and shafts go to the lathe mainly usually. And then
Yeah.
there's stuff that goes to the CNC. So
yeah, especially like if there's anything made out of steel, we try to use the mill because it's a little bit easier because
you can stronger.
Yeah. All right, so we'll get into like how you would do this, but basically when you're doing cam, one of the biggest things you have to think about is balancing speed versus quality, right? So build season, you're always in a crunch generally, especially machining, and you're removing some amount of material, right? And so when you're removing material with an end mill, it requires effort and the tools have to cut that material out, right? There's more effort. So the more material you cut, the more effort it takes for the CNC itself and the tool you're using, right? So what it means is there's a certain limit after which you're overstressing that end mill, overstressing the CNC. So that's why like that's the time versus quality. Because if you're going really slowly with the end mill, right, you'll get really nice quality because it's only doing a little bit of material at a time, right? It's like if you have 4 classes in your senior year that are all like regular except 2 APs, you can do really high quality work because you have all the time in the world. But if you like speed up the CNC a ton, then it becomes a problem because there's so much work to do in your junior year that you're just stressed out. You can't have high quality work. So that's why, like I said, the cam, if we have templates for the cam, there's our starting points. These are values you've tried and tested on the CNC and they're very safe. But once you start going beyond them, it's okay to do so. It's just that be cautious because once you overstep the line, you're going to break something. And you'll also get lower quality. And lower quality is bad because like sometimes for a bearing hole, for example, your bearings won't fit or they're off center, right? That's a problem in terms of performance and also like looks sometimes. Like if the bearing hole has a really rough finish to it, it doesn't look that great. And that's generally not good for assembling things either. All right, any questions so far? I'll switch over to Inventor now. You can type them in the chat or you can just say them out loud. Any questions so far?
For like the contour and like the bearing holes and pocketing, why are those 2 different steps? Why don't you do them in one step?
Oh, bearing hole, like cutting bearing holes out versus pocketing?
No, like, you know how you do bearing holes and pocketing in one step and like cut the shape of the piece you're doing in another step. Why do you do that
okay.
separately?
Well, okay, so basically when you export so we'll get into this later, but when you export your like G code files, you can like group things together. So you can do the pocketing and like the last contour, like the last shape part in one go. So you don't have to stop the machine. Why are those two things separate is because the way the end mill goes around cutting things. So when you have a bearing hole, right, there's a circle of aluminum and that has to be removed, right? So there's a lot of material here that we need to remove. And in order to remove that material, there's a different way the end mill goes. What the end mill does is we'll start at the top and it'll make a little like spiral downwards, and then it'll start cutting small materials out and out and out and bigger. That's what's called adaptive. And then for the final shape, it's different because you're not cutting out a whole bunch of material. You're just cutting an outline out. And for that, the stresses are lower. So what you do instead is you just do a path around, you just keep going deeper and deeper and deeper until cut out the shape. So there are two different ways of cutting something, right? Like if I gave you, let's see, if I gave you like a piece of polycarb that was very weirdly shaped and you had to file that weird shape away, right? You would go super hard at first at it and then change the way you're filing it. But if I gave you a super good piece, you just had to like deburr it, you would go more slowly and you would change the way you file it. It's the same thing. You're doing two different things with two different amounts of stresses. And so you change the way you would run your end mill.
Is he talking about the finishing pass?
Yeah. Oh, no, not finishing pass. Adaptive versus contour. How do you determine which end mill bits to use? Okay, so we'll get into that. Basically, end mills can have different sizes like drill bits. And generally, the bigger the end mill, the stronger it is, right? The bigger the bit, the better it is, the stronger it is, right? But if it's smaller, you can do smaller pocketing. So like if you have really specific and tiny shapes, right? Think of it like high resolution versus low resolution, right? If you have a TV with 4K pixels, the pixels are super small, but that gives you really nice resolution, right? That's the same thing with an end mill. If you have a super small end mill in diameter, you can cut out really fine shapes like the bowl we made on the shooter this year. But if you have a really big end mill, it's stronger. It can do more material at once. It can cut away more aluminum at once.
Wait, also another question. So for like cutting big holes, you say that like you start at a point and then you like cut out small circles until like the circle gets to the desired size. Instead of doing that, like why don't you just cut out like the outline and then like just take the middle part out? Yeah,
so that's a very good question. We'll get into that as well. The reason for that is if you cut out the outline, let me actually share the slide and go back to the picture. So if you see, right, when we cut out, I had another question I had to ask you guys. Anyway, so when you cut out, and you've seen the third picture, right, the bottom one, when you cut out the outline, this middle piece no longer has any aluminum supporting it, right? So you're saying you're going to do the same thing for the bearing hole, except in the middle of the bearing hole, there's going to be what's called a puck. It's a super small piece of metal that was left over because you only did the outline. And now that piece can fly somewhere, basically.
Oh.
Yeah. There's a way I can show it to you on CAM, but the reason why we don't do it is because it's, in terms of time, it's not like 100 times faster, but the problem it creates is you have this puck that you have to deal with and it's unsafe. So that was actually a question I had for you guys is, why do we follow this order? Why do we drill holes first, then do adaptive pocketing, and then we do the final shape? And why don't we go from final shape and then do adaptive and then do holes? Take a guess. You don't have to actually know the reason, but take a guess.
If you went in reverse, there's nothing holding the part you're cutting in.
Yes, that's exactly the reason, right? So if you imagine if I only did the outline of this gearbox plate first, there would be nothing else on this plate and it's already been detached from the rest of this rectangular aluminum sheet. And so it would be free to go anywhere it wants to, right? And yes, we have clamps that we can use, right? But if I was cutting something out on my phone and if I had clamps here and here, all of a sudden I can't cut anything where those clamps are. And if I had to cut anything there, I would first cut everything in the middle, then move my clamps, which is much slower. So that's why we drill holes first. And then what we do with those holes is we put screws into them. So the whole piece stays on our CNC. And then we can do our whole pocketing and final shape. And this wouldn't move because these holes are held in with screws. Okay. You guys have any other questions? When using the CNC, would you stop machining and replace the bit if you want to go from a drill bit to an end mill bit? Yes. So anytime you have to change the diameter of your drill bits or end mills, or if you have to change the tool itself, drill to an end mill, or if you broke your end mill, you have to replace it, you stop machining and then you change it. There are some CNCs that have what are called automatic tool changers, which is basically a whole bunch of fancy systems and motors that stop machining and it takes out the old tool, replaces it automatically. So you don't have to do anything. You just sit there and watch it. But we don't have that. We just manually change it out because it's fine. All right, let me share screen with Inventor this time. Okay, do you guys see Inventor? Is it good? All right. So first off, when you install Inventor CAM, it's not like a separate application. It's an add-on. If you play games, it's kind of like adding a mod to your games. So it's just going to show up on the top here where it says CAM, like next to tools, it'll show you CAM on Inventor. That's how you know it's installed properly. In the case that it doesn't show on yours, I think there's a way to manually add add-ons. But yeah, let us know if it doesn't show up. Just message me, Redfig at the end. We can help you with that. Right. So what you do for camming is first you have to make your part. So make sure you finish your CAD, whatever you're doing, right? And then, so I'm just going to use like a gearbox plate from an old CAD-a-thon. Emphasis on old because this is really bad. All right. I'm going to hit open. And you can see this gearbox plate that's over here. Is this 1/8 inch? No. Oh, what the? Okay. Disregard that. This is a weird plate. I'm going to, I don't know why that was the case, but it's a 1/4 inch plate now. All right. This is what we generally have during the season, right? So this is an aluminum plate. And let's say I want to cam this, right? First thing you do is you go into cam, right? And they'll launch this like interface kind of thing. And oh, what is not showing up here? Oh, yeah. So the first thing is you have to create what's called a setup, right? So you hit setup. And so this basically defines like what your piece is, where does it start? So first of all, the way CNC machines work is like they don't know exactly where they are relative to the whole machine. Like the CNC doesn't know that it's in this corner of the machine. All the instructions on the G code say is that starting from this point, go 10 inches left, go 5 inches right, and cut out this piece. So what we have to do for any time we cam is you have to define an origin point. That's where all my cam will start. That's where everything will be referenced off of. So what we usually use for like these plates is we'll pick one of the corners like that, right? And then what we do is we change these axes here, right? So you see this X and Y. So we'll make the long one the Y axis on the Laguna. Reason for that is our X axis on the Laguna CNC is like a little bit curved. So if you told the Laguna CNC go from right to left, it would actually take like a slightly curved path, which makes it less accurate. So that's why I try to use Y on anything that's super long. But for this plate, it's fairly square, so it doesn't matter, right? So what you do is you go on the left where it says model orientation, select one of these two options, axes, and then you can change the direction of these axes. So what I'm going to do is, let's see, is there any good points here? Okay, this CAD is like kind of bad in that it doesn't have any straight lines here. So what I'll just do is I'll pick like this line, for example, and it will change what the Y-axis is. So now the Y-axis is facing along our part, right? This is important, right? You see how if this was my origin point, any instruction in the Y or the X direction follow where my piece is, right? You see like the red part is inside that box of X and Y. If you did this the opposite way, like the way it used to be before, where it was like this, where the Y-axis is pointing out, what it would actually do in the G code is it would say travel in the negative direction because my Y-axis points away from my part. And what that would cause is when you go on your CNC, your part would be cutting backwards or like it would just go off the CNC, which is not good. So that's why you want to make sure you go model orientation, change one of the axes, and you just pick like the line that's along your part. And then the next thing you see like how this yellow box is here. So this is like the boundary that we're going to use for our cam. And you can see the yellow box is much bigger than our plate. The reason for that is like Inventor tries to give you extra room to work with. We don't use that. We just go in the yellow tab here and change this offset here to no additional stock. That makes it like the size of the plate. Don't know why it's making this huge size here, but that's fine. The reason for that is we add this extra space when we're actually working on the CNC. So that's something you would do in person, but it's not. That's why you do no additional stock here. Yeah, that's it. And then we select our model. This is the model we're going to cut, right? There we go. There's the box in the right size, and we hit OK. So that's our setup. What it is defining what we're cutting and where is our origin point, right? This is a really important step because if you mess this up, all your other instructions are going to be like in the wrong direction. Anyone have any questions so far on this? Preferably speak them, but if you have to use a chat, you can use the chat.
Yes, one other way to like think about it is that the setup sort of pre-allocates material. Like it sort of, that's what CAM software does, is it kind of imagines that there's material to cut on, and that's what you're doing with the setup. So what it does is it creates the material, and then the origin point is sort of where your end mill is starting. So that's what he means by everything is relative to the origin.
Yeah, so technically what you could do is you can get a piece of aluminum that's the size of this yellow square. And if you put it on your CNC and you say this is the origin point, your CNC cut out this plate, be completely fine, right? So the next thing we have to do is drill holes. Anyone have any questions?
Could
yeah.
you go back to what you did with like the no stock and how you changed the box size?
Okay, so if you go in this yellow tab on the top, that's called stock in the setup folder in setup operation. Here in the stock offset mode, you have add stock to all sides, just sides and top bottom, or no additional. We use no additional stock. Yeah, and like I have this, I'm recording this right now. So in case you are trying to follow along, don't worry too much. You can find specific instructions later. Right, so the next thing is how do you actually drill and all that? So what we actually do is we have templates for each operation. So I'll show you guys like what an operation looks like. So if I press drill here, right, I can select that hole. And inside an operation, you can do all sorts of things. So you can, all these speeds here, feeds and speeds is basically like the speed at which it operates. And the feed is like how fast it's moving. So spindle speed, so the spindle is this part that spins the end mill of the drill bit, right? And so there's an RPM for that. There's a surface speed, like how fast is it moving on the surface, how fast is it plunging up or down. The feed is the distance it's traveling per amount of cut it makes. There's all these numbers, right? And there's this tab that defines the heights. There's even more numbers and like settings you can do here. So these are all ways that we're camming something. Like this is how much we're going to go in, and each time you drill something, this is how fast we're going to go. And you don't want to, obviously, you don't want to be doing this every single time. You have to drill a hole every single time to do a pocket. So that's what we do is we have templates. And the way you access those templates is you do right click, create from template, select template. And then if you go in our parts library, so documents, GrabCAD, parts library, in the CNC folder, we have these three setups, right? So aluminum, 2x1 polycarb. So let's say we want to do aluminum. You click aluminum. And then we have our 4 templates here. Drilling, the adaptive, and finishing is for like pocketing. And then the final shape, final contour is for final. I know these final and finishing names are confusing. I'll get into what they mean later. So what you do is just click on aluminum drill, hit open. And then now it will create this operation here for you that has all the correct numbers. So these numbers are like what we have tried in the Laguna and the OMU CNC, and they work. So this way, like you could just run this and you won't have to worry about the numbers being off. And you don't have to set these numbers every single time you can, right? So when you open something from a template, what you have to do is you select one hole, right? And it will select all the holes of the corresponding size. You see in this gearbox plate, all the holes are the same size because they're corresponding tapped holes. And so it selected all of them, right? So the next thing is, if you look here closely, right, it's showing you 2 cylinders. It's showing you a bigger blue cylinder and like it's the same blue, but there's a smaller cylinder inside of it. And what it corresponds to is the bigger cylinder is the actual size of the hole on my CAD, and the blue is the size of the tool I'm using. So clearly this is not the right tool, right? Because it's too small. So you go in here on the leftmost tab called tool, and you click on the button that says tool. And you can see here, right now it's selected a drill that's 0.159 inches, which is not correct because it's a quarter 20 hole. So we go on tool, and then here we can select like what tools we want, right? So you can, they have like their own library, Inventor CAM, whereas all sorts of like tools and things like that. But we have our own library that we use with all the tools we have. And so what you have to do is you have to do, I believe you have to do like new tool. Hold up. I am forgetting how. Oh, there, tool library. There we go. So you can like, in my library. So you do a new library basically, and then you can import a library. So we can call this MVRT2. I already have an import re-imported basically, MVRT2, and you can. Let's just delete this and I'll restart. Okay, MVRT2. What you have to do is, let's see. It's been a while since I CAM, so I have to like remember things again. Okay.
When you right click, it says import.
Yeah. One sec. I'm trying to. Okay, so tool library. We want to do a new library. Where is that option again? Oh, there we go. New library. Please create a library in another folder. Okay. Add library folder. There we go. So we add a folder for our library. Documents, GrabCAD, parts library, CNC. Oh wait, there's no full. Never mind. This is bad. Okay. As you can see, I'm having a lot of trouble. Add library folder, documents. Okay. Ah, there we go. Now I can just edit the name here. So let's make it my library. My library. And then in here, I can import a library, or never mind, maybe I can't import it. Where did it go? This is very bad. Okay. Let me, why is this being so annoying? Okay. New library. Import tools from library. There we go. Yeah. So now when you go in our CNC folder, sorry, that took a while. There's this file called 115_tools.hsmlib. That's our library of like tools. So you hit open, and now you'll see all these tools in here. So let me just rename this to. There we go. MVRT tool library. And, okay, there. So these are all the tools we generally use, right? So there's an 1/8 inch end mill. There's a 4mm end mill. There's a 6mm and a 1/4 inch end mill. And then there's all these drill bits we have. So the smallest size is like 0.116 inches. That's for 440 screws. And you go all the way up to 0.257 for 1/4 20s. We generally don't do holes that are far bigger, so we don't have a tool here, but that's besides the point, right? So these holes I said are 1/4 20 tapped, right? So we use this tool, hit OK. And then when you go in here, oh, so you click on tool, and then you find your tool library, you click on 201, select, and then when you select a circle, you see how the two cylinders overlap now, and that means they're both the right size. So this is good to go, right? And so in here, if I wanted to, let's say I felt this was too slow, if I was actually machining it, I could bump up the speeds here. If you've seen the cycle, it says chip breaking. What chip breaking means is basically instead of going all in and then out, what it does is it's like a woodpecker basically. It goes a little bit in and a little bit in, a little bit in, a little bit in. And the reason for that is so that we don't like try to drill everything out at once, right? Because that's like bad because you're trying to do all these things at once. So it does a little bit at a time. And these settings here are basically how much does it peck at each point, how much time does it take to do it, and then dwelling period is like, does it stop after each peck or does it like just continue going? Here in the heights tab is basically where you define like, so this red one is clear, the orange one is like clearance height. So that's like, what is a safe, super safe height above your part? And we have it at 0.4 inches. What that means, it tells the CNC that if it's 0.4 inches above our part, it's good to go. It's not going to run into anything, right? The height here, the yellow one, the retract height, that's like when it's moving between this hole to that hole, how far up should it go? Because obviously if it goes up too far, we're wasting time going up and down. But we'd also don't want to scratch our aluminum, right? And then if you notice, right, if I do a side view, not that view, if I do this view here, you see how this blue line here, that's actually below the red CAD itself, right? And the reason why we drill that little bit more is because our aluminum plate, our table, CNC table, isn't super flat, or like it's fairly flat, but it can have variations, right? So even if I made this blue line up here, it might complete a hole over here, but this hole might have a little bit of aluminum left on the bottom. So to make sure we drill completely through each time, we go a little bit more below the aluminum. And it's not that much, it's like 0.03 inches, right? So there's that, and then this face, so this here is like, how do you want to select all of them? And so the template already has this, but if you select one hole, it'll select all other holes of the same diameter. And you hit OK, and it will do what's called generating. So it'll try to come up with a way to do it. And you can see it shows you like the way it's going to go. So you show the green arrow is like where it's going to come out of, and the right arrow is where it first goes in. And it goes in, drills, comes out, moves over, and does this. Seems like there's a chat. So how do we know which template to use? So the templates are like fairly self-explanatory. Like there's a drill, and then there's pocketing, adaptive or pocketing, and then there's like a contour for cutting out shapes. So there's not like too much work to it. So you do drill. Let's say if this plate had other holes, what you would do is you would do another drill. So you come in, drill, and let's say maybe we had a drill bit for bearing holes, right? If I were to select that, it would select those two holes, and I could find a tool for that. We're not going to do it, but if you had holes of different sizes, you could do that. Let me delete this. Right, so the next step in our camming process would be to do the bearing holes / pocketing, right? So what we do is you right click, and then once you select the drill one, all the aluminum ones will come up in here. And then what you can do is click on aluminum adaptive for pocketing, right? And this is another template again. And you come in here and you have to select each of the pockets you want to do. So I want to do the bearing holes. I'll select those. And you see how it creates this like blue highlight? That's basically where it's going to be cutting. And you see how the arrow is on the inside of the perimeter of the circle? That indicates that it's going to cut everything that's inside the circle. If I click on that arrow, it will cut everything outside the circle, which would be the entire plate. But we don't want that. So I click on the arrow again, it'll cut everything that's inside my circle. And we can do the same thing for all the other pockets. So I'll click here, click there, and there. As those are all our pockets we're going to be cutting, and this one as well. Now in tool, so you have a choice of mainly 4 end mills that we use. So the 8 and the 4mm one, right? They're the smaller ones. So those, we try to not use them as much as we can because they're smaller. So they take more time to cut the same amount of stuff away, and they're weaker, which means that it's easier to break them, right? So what we try to do is we try to use the 6 and the 1/4 inch ones. Now we used to, like in 2018 and before, we used to use 1/8 and 1/4 inch end mills only, but then we found these 4 and 6mm ones that are much cheaper and they have like similar quality. So that's why we just use the 6mm and the 4mm ones more commonly now. And so for like pocketing, I would just click on the 6mm one, hit select, and it should select all your pockets. Sometimes it like forgets all the pockets. So you just have to select it one more time and it'll be okay. Should be okay. There we go. All right, so all the pockets are still selected. So that's our tool. And again, here are your feeds and speeds, right? So these are the RPMs and like the numbers that we have tried on our CNC linear work. If you felt like this was going too slow, you can always speed them up. But always remember, proceed with caution. And then the heights here, it's a similar thing to the drills where if you look at our bottom height, it's a little bit lower than the part itself. Again, reason being, we want to make sure we cut through everything. Let's see. So passes, this basically is determining like how it should be cutting stuff. So the direction is, does it climb into it or does it go the conventional way? It has like blur throughout everything, so you can read more into detail if you wanted to. Stock to leave. So this option is checked right now in the template. What basically this means is, do we want to cut smaller than the actual size, right? So if this is 1.125 inches, do we want to cut only 1 inch? And you might be wondering, why would you cut it smaller? The reason for it is, remember when we said speed versus quality for CNCs? When you have to cut a lot of material away, you're gonna doing a lot of work. And if you do a lot of work, the quality goes down. So when you're doing all this pocketing, right, you're removing all this aluminum away, the quality can be really bad if you're going fast. But you want to go fast so that you don't waste time just watching a slow CNC. So what we often do for getting a really nice finish and not taking forever to do it is we'll cut a 1 inch or like 1.12 inch hole with our adaptive, do it really fast, have a rough quality. And then this last 0.005 inches, we'll actually go in and we'll do it slowly so that we have a really nice finish left on it. So that's why we would do it. If you just wanted to cut your pieces out for the first time, just uncheck it. It's totally good to go. In linking, this is where we can do other things. So let me first hit OK here. And you'll see it'll try to generate the path for it, right? And you see how, so this is the thing where I was talking about it helixes down. If you look at this, let me change the color here. Clear, override. There. So if you see these red helixes, right? That's the path the Enmo will take. So first it will go down in a spiral. If you imagine that, if it goes down in a spiral, it creates a little hole for itself so that the chips can like escape out of the end mill, right? They're not stuck in the end mill. And then we just do this circular like orbit that keeps getting bigger and bigger to make our actual bearing hole. And we do a similar thing for pockets, except it's like weirdly shaped because it's not a circle. Yeah, and so you see the angle at which a helix is down, right? That's something you can change in your pocketing settings. So if you go in here, in the last one, if you scroll down where it says ramp type, right? So you can do a helix, you can do other types of ramps, and you can change the angle. So if you wanted to, if you thought that angle was too shallow, you could make this 10 degrees and it would go down much faster. Yeah, and then leads in and transitions is like, if you have a part, I think it shows a good picture here, or not. It's going to show me a picture. There we go. So if you want to like go into a hole, right, you can do a lead in, which would basically take the end mill. It will like be very carefully step into the pocket you're trying to make, basically. That's what a lead in or lead out would do. Yeah, and then these other numbers here are for how much should it stay down when it's cutting? Should it like come up each time it's cutting? If you have like really complex geometry that's like super fragile, you want to always lift up your end so you don't actually run into something, right? So we don't need any of that. This is adaptive. And then the final thing is we need to cut out our final shape, right? So what we do is we right click, create from template, final contour, right? And then we do this. Remember, we have to change our tool. It's already 6 millimeters, so it's good to go. And we just select the outer perimeter of our part. You see this time the arrow is on the outside, right? If I were to put it on the inside, it would cut out the inside, but that wouldn't work. We don't want that. So we put it on the outside. Here, rest machining, again, this is like the portion where you, this is rest machining is actually different, is if you cut something before, you just want to skip that pocket and get into it. But we don't need to do that here because it's just an outer shape. Nothing's been cut here before, so we wouldn't use rest machining. The way you could use rest machining is, let's say you want to split up your bearing holes. So you could do your 2 bearing holes first and then do pocketing. But obviously you wouldn't want your CNC cutting the bearing holes out again. So that's how a rest machine could be used. Again, same thing with heights here. It's a little bit lower than our part. In terms of passes, so this is where we do what's called multiple depths. So 1/4 inch aluminum is pretty thick, right? And if you're an end mill trying to cut all 1/4 inches of it really quickly in one pass, that would be very difficult. You saw in that video that I showed you guys with the end mill, it wasn't cutting all the way through. It was only cutting like halfway through. So what we do is, instead of trying to cut 1/4 inches of aluminum at a time, we cut like what it says here, 0.04 inches of it at once. So that way our end mill isn't working super hard and we can go fairly fast. And so we do 0.4 inches, 0.04, 0.04, 0.04 until we get to our 1/4 inch aluminum. And here you can add like ramps to it to change like what the angle is, right? And then if you go in the last tab here, there's a ramp there. And you can do a lead in or lead out if your part is like if there's a very like specific pocketing that's super fragile, you need to go into the contour when you're doing it. So when we hit OK, you see there, it generates our path. You can see there's multiple lines here because it's going to go multiple rounds around the contour. And so that's basically CAM. Now, if you wanted to check if it was working or not, you can select all of them and do simulate. And then here it would actually run your part through. So we're going to do that and we're going to check stock so that basically we can see what it would look like if we had material here. So it would start with all these holes. This would happen on the actual CNC as well, right? And then we would put in our screws here while pausing it. And then we get to our pocketing. So you see how it, let me slow it down a little bit. So it does those circular things. Let's see if it moves. Yeah, so it's going to move to a new pocket now. It goes there, and then it does this little helix pattern downwards. That was the ramp we did. And you see it creating this big space for itself so that the chips can like fly out and they don't get stuck anywhere. And then once it creates that big hole for itself, it starts moving outwards. So if I did a bottom view, you could see how it's like gradually getting bigger and bigger and bigger. And then there's all this empty space on the inside so all our chips can escape. All right, and we get here, and then it starts doing weirder shapes because it's trying to cut out that pocket. So we'll do like small motions there, it'll do motion here. And then we'll do a motion there, right? And then we can speed this up so that it does that, right? It's doing all of that here. So that would be the end mill actually cutting this out. And then keep doing that for those pockets, for that pocket, for that pocket. And then we get to our final contour in a bit, right? So it's gonna go up, it's gonna come to a side, and then it's gonna do our ramp. So see how it's ramping down? It only cut a little bit at a time, right? It didn't cut all the way through. And it goes down even more this time, cuts more out, right? And goes around again and again. You can see it's getting deeper and deeper, the cut itself. So it's gonna come around and it will cut more this time. You can speed that up a little bit more. Right, so it goes down and then it's almost done there. And it'll come around one final time and it's finished cutting everything. Right, and then what we left with is your final piece there. So do you guys have questions in this portion?
Do we still have to do the finishing contour?
So the finishing contour is basically, so remember in adaptive, we had this portion where you could do, it was here, stock to leaf, so that you wanted like higher quality, right? So what we do is, so axial means like up and down an axis, and then radial is like outwards, right? So we want to do radial, we want to leave 0.005. You do okay. So this would actually cut out, the adaptive will cut out a hole that's 1.12. And we need to do that final 5,000. So what you do is finishing contour, click on that. And then you would select that and that. I'm just gonna do 2 bearing holes for now. 6mm end mill. The rest is just like a contour. Do okay, and I'll just do a final pass around there to your finishing. Any other questions? Oh, I think there was a chat somewhere. Oh no, that's all. Okay. Any other questions?
No, I think that's about it for this.
Okay, and then I'll show the thing Sai was talking about, like, why do we do this whole circly thing? Why can't we just do an outline cut? So if I were to do an outline cut, which it would be called a contour on, let's say, a bearing hole, right? Hit OK. It will generate, and let's simulate this. So you see how it's cutting that outline out, right? You see that piece in the middle, right? You see how there's this middle piece that never got cut, or that never was like removed. And that's a free floating piece of aluminum without anything holding it down, right? And remember, the end mills is spinning in like 15,000 RPM, 12,000 RPM. So when that thing touches that free floating piece of aluminum, it flies out. So that's why we don't do the whole, just do an outline thing. And if you ever do have to do it, is if it's like there's a really big pocket and it's going to take forever to cut everything out of the way, then we just put screw holes in the middle so that it doesn't fly around. How do we hold the aluminum sheet to the CNC? Right, so that's where we use clamps. So the edges of the CNC have like clamps on them, and you just clamp the edges of the aluminum and you cut in the middle. But it's okay for the whole big sheet because we have 4 foot of space to work with. But if it's for this small part, if you put clamps on this, like you don't have any place to do the pocketing.
For this part
Mhm.
specifically, because we didn't leave any like extra stock,
Mhm.
there's like very little room for the clamps to go. So if we were gonna do that, like,
Yeah, you wouldn't, it would be very difficult to do clamps here.
okay,
Like the way you would do it is maybe you would put clamps on the sides and then only do your pocketing for your bearing hole and things in the middle. And then you put your clamps in the middle and you do things on the side. So that's why it adds like extra steps to your machining.
Also, real quick, I can just explain like the usage of lead-ins and lead-outs. So the only, I remember John roasted me for not knowing why, but basically the whole point of having a lead-in and lead-out on this is mainly for the final contour, is that it makes your final pass as smooth as possible. But what it means by that is, Justin, could you make it so that way you look at the like one of the pockets in like one of the bearing holes in like a side view, not really side view, so you can like show me something like that. So what happened is that the tool would go like that, right? And at the end, it's gonna go like it's gonna do its final pass. But what's gonna happen is that when you start, you want your tool, your end mill, to take a path that starts like that. And the reason why you want to do that is because you don't want it to like plunge in there. And if it plunges in there, like if we were to not have a lead in, then it's just gonna go like boom and then like that. And the
Leaves a mark, yeah.
yeah, so the reason why you don't want that is that it leaves a mark, as Justin said, and it's not smooth at all. So you want to like start off like tangentially rather than going linearly, if that kind of makes sense as to like how you'd want to go. And the same thing goes with leading out. Like if you end over here, you want to end by like rolling out. So that way you can, like, that's the whole point of a lead in, lead out. You don't need it. It's just to make it as smooth as possible. But like that's something that it's like super nitpicky. So it's not absolutely necessary.
Yeah, you can also think of it as ease in and ease out, where you're easing into your part so that you leave the least amount of visible damage to your part, and you're easing out of it so that there's least amount of damage.
I think I have my one of my plates, which
I have my old plates at home. But
yes, if I can find, I can show you like direct example.
Yeah, I have lots of examples of bad practice machining wise, but do you guys have any other questions?
So for the lead in and lead out, is it only for the contour?
You can do it for anything with an end mill, adaptive or contour. But yeah, for adaptive, actually, because you start in the middle portion, like you don't need the middle of the bearing hole anyway, right? So the lead in doesn't matter. The lead out would be useful. For contour, they'll lead in and out because you're cutting the entire shape.
I don't know if you guys could see it, but if you guys can see it on here.
Let me stop sharing and highlight Rhythmic.
All right.
Spotlight. There you go.
Yes, I can see myself. Let me find it first. Let me find it again. It's right over where my pencil mark is on.
Yeah, so we're gonna see your pencil mark from here. Oh, you can kind of see it.
Here, you see that over there? Where my pencil is over here?
Yeah.
Really, really hard to see, and you can't really see it on Zoom, but there's like a plunge mark over there, and it shows like a line where the end mill was. So like, you know, obviously me looking at this plate after like 12 months or like however long that it's been, I can still see where the end mill was, right? So like that's what he's trying to do by minimizing the damage, because like it's visible, but like it has absolutely no like effect. I'm sure that like a bearing is going to fit in there anyways, but
Yeah. Right. So with the 4 minutes we have left, the final process for actually being able to put this part out in the CNC would be you select it and you do post-process. That's the compiling portion, right? So remember that we have to drill and we have to put screws in, right? If we're on a CNC. So you don't want to select all three at once, because what this would mean is all the G code will be right next to each other. So the moment it stops drilling, it would go straight into making the pockets, which is not good. So what we do is we just process drillings all by themselves. And if I had to switch, like, let's say I wanted to do my, let's see, what is this contour? This like 2 bearing hole contour. I wanted to do that with a 1/4 inch end mill, right? And then for some reason I had to switch my end mill for my final pass. If you have different tools, you need to switch those tools out manually, right? So you need a pause in between, and that pause comes from if you don't post process them together. So we're gonna hit post process here. Let's hear a chat. If you replace a drill bit, would you use different G code files? Yes. So basically your USB would have like a G code for your 1/4 inch drill, one for your 10, 30-second drill, etc. Right. So you hit the drill button, you hit post process, and then it will load it. And over here in the post processing, there's a whole bunch of CNCs and like their post processors. This is basically like the compiler for each CNC. And you have to find the right one. And like Inventor CAM doesn't come with the one for a Laguna. So that's why what you have to do is you have to go in your file explorer, documents, GrabCAD, parts library, CNC, post processors, and this has 3. So the Laguna is for our Laguna CNC router parts, that's for the Omeo, and Glowforge is the laser cutter we have. So that's a similar process, but I'm not gonna go over laser cutting because I don't know either. But what you do is you take the Laguna .cps file, that's the post processor, the compiler file, and then you go into this PC, and then users, public documents, Autodesk, Inventor CAM, posts. That's what they're called, posts. And here you have all the .cps files. So this is where you would copy paste the file. I went through that pretty quick, but you can like rewatch the video for that exact file path.
Jonathan, I
Uh-huh.
can't see. I can't
Yeah,
see
we
it.
can't see that part. I don't think you shared.
Oh no. Oh no. Do you see it now?
Yeah.
Oh no. That is tragic. Okay. All right, let's restart. So you go on documents, GrabCAD, parts library, CNC, post processors, right? You have Laguna, Glowforge, and CNC router parts. Laguna is for our CNC, Glowforge for the laser cutter, and CNC router parts for our Omeo. So you'll copy that file, Control C, and you go to your PC. So this PC, users, public documents, Autodesk, Inventor CAM, posts is the folder and has all these .cps files. So I would copy paste it here. I already have the Laguna one copied here, right there. All right, so once you have it copied over, you can use it in here. So you click on Laguna, and then the unit here is very important. Both our CNCs run on millimeters. So if you were to leave this as document unit, and most of us use Imperial for our CAD stuff, right? It would convert like 2 inches to 2 millimeters. So your part would become like this tiny, super tiny part, which doesn't work. So make sure you change the unit here to millimeters. And then program, you don't have to worry about program name number. That's just like the file name. So you do Laguna CNC, you hit post, and it'll try to save it basically. So this is where you add a file name. Now, we have a naming convention for CNC, but it's less troublesome in order to make it, and it's far more useful, right? What we do is we start with a letter that, I like how Arnold's laughing at the useful part. Anyway, you start with a letter that indicates the order, right? The order as in, what do I do first? Do I drill first? Do I contour first, etc., right? So for this is the drill one, so I'll do A. And then this is a 201 drill bit, right? So I'll write 201 and then drill. And that's it. That's my file name. So it's the order I'm doing it in, and it's the tool I'm using. The reason for that is in case I had someone else cut this out for me, they could see what they have to do first and which tool they have to use, right? So A201 drill. And then usually I would just make like a new folder for, let's say, WCD CAM, right? Or post processor or whatever. And in here, I would save this. So save, and it'll automatically save it with the right extension. And now these two contours, assume they were using the same tool, right? They're both 6 millimeter end mills. I can post process them together because I don't have to pause in between. So I select both of them, post process. Once you load the Laguna and the millimeters, it'll automatically load itself. So you hit post, and then this time we'll find that folder we were in before. So WCD CAM, and then this time we'll do B because the second operation, and we're using a 6mm, and then you can just do end mill, or you can do end or contour or whatever. Something to signify it's not a drill, right? Be 6mm end mill, hit save. And now if I were to hand over this folder to somebody else that didn't know what my part looked like, they could still cut it out because they just set it up and they do a 201 drill. So they go first A, find a 201 drill, use that. Second operation, 6mm end mill, use that. Right, and let's see, there's a chat. When do we know which CNC to use? It's just whatever. Yeah, so this season I tried to use a spreadsheet for keeping track of like what's being machined on what day. Like if we're planning on machining something so that you could see which one's being machined. That it kind of worked at the start, but it was kind of cumbersome to keep track of, so it didn't really play out as well. But yeah, just keeping track of like what's being machined on other machines, calendar kind of thing, and whichever one's free, you use that. The post-processing takes 2 seconds. So like you can just have your cam done. And then once you have to post-process, you just post-process whichever one you need to use. Another thing to note is in the setup, it tells you the size of this yellow box. If you go in the last one, or no, the second one, it tells you the width and the depth. Right, so like this is 3.7 by 3.9, so 4 by 4 inches is basically like aluminum, the stock somewhat. And so when you're actually cutting it, I would look for a piece that's like this size plus another 1/2 inch-ish, so that you know you have enough material. Like if this was 4 by 4 and I put a 2 by 2 piece of aluminum on there, it wouldn't work, right? So yeah, that's that. If you have any questions, you can stick around. Otherwise, you're free to leave. And you can like DM me if you have any feedback about how it went today. I think it was a little bit fast, but should be okay. Bye, Osam. Stop recording. It's recording, Ritik.
That was very educational, sir. I learned a lot.
Did you, Akash?
Yeah, I actually paid attention. That's pretty interesting. I'll never use it ever, but yeah,
are you sure you don't want to machine another bowl?
I think I'm good. You know,
Please, Akash, I think you should learn the mill and the lathe as president. You would be a wonderful machinist. I think the machine shop is your future.
Oh, yeah, that was actually pretty interesting. Good job.
Do the others have any questions, or are you guys just sticking around?
Hello.
Hello.
Neil Thresh, get up.
Arnav, do you have questions?
Get up right now.
Struggling with nest.
You're struggling with what?
With nesting.
Oh, nesting. Oh.
That's 3 days from now's problem, man.
No. He's
downloading it.
Oh.
Downloading.
Oh, I thought you were ahead of the game. You were looking at the nesting video I made on the website, but no, he's just struggling to download it.
I have downloaded on one device. I need to do it on the other one. So
that's unfortunate. It didn't even take that much time. Like honestly, it took.
Yeah.
It's like a 10 megabit file. I'm pretty sure both nesting and cam.
If you can download Inventor and GrabCAD, you can download nesting.
I don't know where to download it.
Oh, it's the same thing as the education software link that we sent.
Instructions are literally on.
It's you know how it has all these boxes with the different products.
Yeah.
Right under Inventor CAM, there's Inventor nesting.
Yeah, I tried doing that on my original account, like the one I've been using, and it says you don't have an educational license, and I'm so confused now.
Are you not a student?
I mean, I downloaded both CAM and Autodesk before.
I had to give my transcript and everything.
Oh no, you can just use your student ID card.
Student ID, which is
it takes like 10 seconds. It's pretty fast.
Yeah.
I'm surprised they did it so quickly. I think you can literally just send a picture of
What if all they do is just check the
I don't
file
even.
name?
Yeah, I don't even think they check the actual.
Yeah, what if it's just like if the file name has school in it, it's okay. Okay,
Wait,
I'll.
Jitin.
Uh-huh.
Yeah, so like when I open Inventor, it's like licensing.
Licensing errors.
Yeah. Wait, can I share my screen so you can?
Sure. Share screen.
They send you an email